Dzień dobry Państwu, nazywam się Pawel Wlodarek. Przedstawię prezentację dotyczącą identyfikacji czynników i warunków przyczyniających się do ciężkich wypadków rowerzystów. Analiza ta jest z wykorzystaniem tzw. analizy asocjacji. Nie mam niestety dostępu do prezentacji w tej chwili.
Access to my presentation, so please give me permission so that I can change the slides myself.
Okay. Chyba już jest. Tak.
I think I've got it now. Thank you.
Tak jest. Jeśli spojrzymy sobie na ostatnie 9 lat na statystyki wypadków z udziałem rowerzystów, to w Polsce w latach 2011-2019
in Poland between 2011-2019 we had on average some 250 to 300 deaths and almost 4,000 injuries, and that's purely cyclist accidents.
Gdy spojrzymy na statystyki dla
in a year. When you look at Warsaw itself, then each year it ranges from 1 to 5 deaths, 2 to 25 serious injuries, and in recent years, more than 150 people annually with slight injuries. So very bad data, making Poland at the top in terms of cyclists as seriously injured and deaths across the EU. So the things we analyzed, we used the CARE database with more than 21,000 accidents and records. In fact, that's 2009-13, 5 years. So what's in that database? Number one, it was accident severity involving a cyclist, a fatal, serious or slight. So obviously most of the cyclist accidents involved a slight injury with 1,500 deaths. Next location of the accident, was it in an urban area or outside it? Most of the accidents, almost 18,000, occurred in urban or built-up areas. The specific location, was it at a junction or outside it? Less of that at junctions, more outside of junctions. Was traffic signalized or no signalized traffic at all? As we can see, the overwhelming majority of the cases involved unsignalized junctions. And the time of day, was it during daylight, was it at night time, or perhaps during twilight? And the final item there was the type of road. Was it a one-way or a two-way road? Was it a single carriageway or a dual carriageway? So 21,000 records, that's how many there are in the database, and so that were the data. So I'm going to focus on accidents at junctions. If we were to differentiate these accidents, we would have a category of urban and non-urban areas. Urban area 7,428, non-urban area 487 accidents, of which fatality rate was at 3.9%, and in areas outside built-up areas, the fatality rate was much higher at 19.3%. Well, that's just to give you an example. Now, what would be the basic analyses that we can do using the database? There are 5 features which describe the conditions for each accident? Well, I'm afraid they cannot be presented all at the same time in the same chart. So try and imagine a basic 3D analysis that you can see in the corner right-hand side, where you can see whether it was at a junction or not, and what was the time of day, night or day. So we can do this for a specific number of variables, but a 4D or 5D analysis wouldn't really be possible. How do you show the number of casualties using a chart like this? So the question is, how do you pick a specific set of features which are typical for serious injuries or fatal accidents? We have the association analysis that can help us. In fact, it's called basket analysis, and because a lot of times it's used for such analyses when it comes to shopping. But there are really two indicators there. One is support and the other one is confidence. What we're looking at is B, representing body, and H, which is head, which is the successor. That was the predecessor, and that's the successor. Head or consequent, body or predecessor. So, and then you look at the confidence levels there. I'm afraid looking at confidence only could be misleading, and this is why we also use the lift rule. What it does is it divides confidence over the probability of head appearance. And the rules where lift is below 1 or is based on a few cases, so those rules are insignificant, meaningless. So how do you find the rules in the association analysis? Here's what we did. We adopted specific conditions which we input into the software. Confidence over 50% and support over 0.2%. It seems that support equal to 0.2% is very low. But one thing to note is that the database we're using has more than 21,000 accidents, which means that 0.2% really translates into 43 cases. And all the rules have to have a lift above 1. So how do we find the rules? As we search the database looking for the rules, and because we focused on deaths, the result was a low number of rules, many of them really insignificant. And so we decided to combine fatal and serious injury accidents, and we formed a single indicator, which we refer to as FS. So we aggregated the data by combining cyclist accidents, which ended in death, and serious injury. So what we found was that there were no rules for FS in urban areas. But if the reverse were to happen, which is accidents involving slight injuries, we actually saw some positive results because we were able to identify some rules. And now let's analyze a few of the rules which we identified using the association analysis. The first four apply to slight injuries in urban areas. So rule 1, if the accident is at a junction, that's junction 1, in an urban area, the likelihood is at 72.3% that the cyclist's injuries will be slight. The support for this rule is at 30%, which means that the rule was confirmed by 3,353 cases. And you could say that it's a very strong rule. When it comes to slight injuries in a non-built-up area, non-urban area, well, let's look at number 5. So where we have a junction, a signalized junction, then more than 65%, that's the likelihood that a pedestrian, if involved in an accident, will suffer slight injuries. So when it comes to slight injuries in non-built-up areas, then looking at Rule 8 and 9, the only difference between the two is that sometimes the junction is signalized and then it's not signalized. And then whether it is a signalized or non-signalized junction, that doesn't really make a difference when it comes to the strength of the rule, which means that outside an urban area, it's likely to say that having signalized or non-signalized junctions doesn't really matter when it comes to accident severity or in fact having a slight injury accident.
And then finally, are there any rules for FS, fatalities and severe, that's accidents outside urban area? Based on the rule number 12. So, if we're at night or at twilight, so not daytime, and if the accident is taking place outside urban area on a dual carriageway, because dual is one, then there's a risk of 70% that it will be a fatal accident or with a serious injury. This risk is even higher, even 80% if it's at a crossroad, it's a junction. Now, what are the conclusions? The share of fatal and serious injuries in an urban and in a non-urban area is very different. So we recommend running separate analysis for urban versus non-urban areas. In our analysis, we did not find any rules with confidence higher than 50% for fatal or serious injuries in urban areas. In case of accidents that took place during daytime, traffic lights did not affect the number of victims with light injuries. So basically, the existence of traffic lights in urban areas has no impact whatsoever on light injuries, accidents. On the other hand, there are no meaningful rules for fatalities and serious injuries in urban areas. In case of urban areas, twilight or dual carriageway increases the risk of fatality or serious injury. An analysis with the use of 2 or more variables is, of course, possible with the use of a simple spreadsheet, but this is very labor-consuming and very difficult to do. association analysis allows for an automatic finding of supporting features and strong rules. Strong rules just find themselves automatically. Comparing the rules, even the weak ones, you can clearly indicate which factors need to be changed in order to reduce the number of fatalities and accidents. And of course, increasing the database and adding new items, we could acquire more valuable rules using this association procedure.